Supplemental math videos from Circle Christian School. The distance and midpoint of two coordinates, or technically what we call the length of a line. Ever need to know how far it is from point A to point B? What is the length of the points? Where's the middle or the midpoint? Well, those are all very interesting questions that, if you can answer them, would make our friend Renee Descartes extremely proud.
I owe it all to a little spider.
The distance of a line, also known as the length between 2 points, say for instance the length of line segment AB, is what I kind of refer to as sheet cake. And we have our basic coordinate plane distance formula here. And I'm just going to remind you that as you use the distance formula or even the midpoint formula, it's always good to build yourself some sort of template to incorporate the values that are given to you. So I'm going to go ahead and build a template here. That means I'm going to take away the values and just add all the necessary information. This is actually how I build this particular template. I begin with a little bit of the order of operations, parentheses, power, and then in this case any multiplication or subtraction from left to right. I call it my little sleepy owl. Second thing I'm going to tell you to do anytime you use a template is to make sure that you label. You need to know what your first coordinate is and what your second coordinate is. In geometry and other factions of mathematical life, we actually call our first point, whatever it may be, our initial point. And our secondary point, the place where we end up at, as the terminating point. And I can just hear Arnie say, "I'll be back" on that one. And now we're just going to plug everybody in to the equation. So we're going to start with our second x. Remember to include the signs. It also helps to use a different color. And then our first x. And then I'm going to use my second y. And then my first y. Now it is possible to go the other way. You just have to remember, whatever you use first, you have to use for the other part of the coordinate, the y coordinate. And now we're going to do the work. Remembering that everything underneath the radical is what we're going to be working with. And this is going to give us a -4 squared. Make sure you keep your parentheses here. Biggest mistake that I see students do is not keep their parentheses. Any negative number squared is always going to be positive. As a matter of fact, any distance, any length is always going to be absolutely positive anyway. So we're going to have 16 plus the 4. And that's going to give us a square root of 20. Generally, you like to take your square roots and simplify them into their lowest terms. I like to do a prime factorization tree. So for instance, I have 5 and 4. The 4 can break down into 2 and 2. These are going to give me all my prime numbers. It takes 2 for one of them to escape. So my 2's are going to come out. And the rest stays underneath the radical. It's actually a more perfect number. So 2 to the square root of 5 is going to equal the distance, or this length. Now, if what you're doing is using a measuring tape, obviously you would evaluate and estimate on your calculator. Next, we're going to find the midpoint of any line between 2 points. Again, we have A as our initial point. And B is our terminating point. And the M value is actually going to be our midpoint. Now to find basically where the middle is for any two given coordinates of a line segment, you're going to use the midpoint formula. The average of the x's divided by 2 and the average of the y's divided by 2 yield us with our middle or our midpoint, the guy in the middle, x3 and y3. But the most common question that happens inside finding midpoint here that students seem to have trouble with is when you are given actually a initial point and a midpoint, but you have to go find the terminating point, the guy at the end. Well, in the algebra way, we're just actually going to go ahead and plug things in, remembering to label all our information. This is going to be x1, y1, our initial point. This is going to be x3 and y3, that's our middle. And of course we already have our x2, y2 here because that is our terminating place. And now we're just going to again build ourselves somewhat of a template. Let me white that out. Somewhat of a template for what's happening here. So to find the endpoint of our x's, we're going to take the first x, which we have is 3, and we add it to our second x, which is our x squared, divided by 2, and we know that it yields a x in the middle of a -1. Now taking a look at this, you'll realize that what you basically have is a fraction equals a fraction. So we're just really going to cross multiply here. And we get a -2 equals our 3 plus our terminating point at the x's, x2, minus the 3, minus the 3. And doing the math, you'll see that the terminating point for our x's here is at -5. And similarly, we're going to do this with the y's. We have our first y, which is going to be 6, plus our terminating y, divided by 2, yielded our midpoint, or y3, which was 8. And again, we're just going to cross multiply here. So we have 16 equals our 6 plus the y squared. And minus 6, minus the 6. So you'll see 10 is our terminating point for B. Now that's actually the algebra way. However, we can think about this in the geometry way also. Number 1, plot it in a coordinate plane. You will be able to see how far it is from here to here, the direction. Fold your paper in half and you can pretty much figure out where B's at. Another way to do this is that if A is 3, 6, and your midpoint is -1, 8, we'll just take a look at what was the difference that happened in between these. In other words, what did it take for the 3 to get to the -1? Well, we took away 4. So now if we take away 4 again, we get our -5. Now we're going to deal with the difference that happened between the y's. What did it take for the 6 to get to the 8? And we see that we added 2. So to get to the 8, to the terminating point, we would add 2 to the 8, which would give us the 10. And is that not what we came up with in the algebra? I I can just hear it now. Your mind has exploded with coordinate cacophony.